Hey there and welcome. So this is a post-course video. I've had a few comments just regarding a little bit of confusion around some of the topics in this section, and I didn't want to interrupt the flow of the lectures or the section, so what I've done, I'm going to put this at the very beginning of this section that you're watching now, and it's relating to linear interpolation of movements and rotation. So if that's something you're not familiar with, this will definitely be worth watching before we dive in and add some of those components to the playership. So essentially the questions just revolve around when we add the introduction animation to the player ship, we lerp the location and the rotation of the ship at the same time. And people, I think, are a little bit confused on what's the difference, because they're fairly similar, but they are approached in slightly different ways. And if you're not familiar with what lerping is, it is basically short for linear interpolation, which is the interpolation between two different points, so your start point and your end point, and it provides a smoothing between those 2 points. So the kind of effect you get if you lerp something is this. So this cube is lerping forwards and backwards along an axis, and this cube is lerping around a rotation in its transform. And I think these are the points that I probably need to address. I think this is where people are getting a bit hung up. So that's what we're doing in this lecture. So to begin with, we'll look at the cube with the blue mark, and we'll actually look at the whole transform in one go. So what we're doing, as I said, is we'll be lerping between two locations, and the orange cube will be lerping around a rotation. So let's have a look at what those are. Over here in the transform box, we have location, and you can see that all of these have an X, Y, and a Z. Now that's essentially just a vector 3, and a vector 3 is just 3 floating point values. So if you're familiar with any kind of rudimentary mathematics, you'll probably be familiar with what a vector is and what a floating value is. Now what's really useful is in the engine, if we highlight over any of these, so if we highlight over the X, we'll get a tooltip telling us that this is the X value. Over the Y, we get a tooltip saying the Y value, and likewise the Z will get the Z value. Now, where this gets slightly more, maybe not complex, but just confusing for some people, is that you also have the rotation represented as an X, Y, and Z, but that's not quite true. When people talk about rotation, it's normally done in yaw, pitch, and roll, not necessarily in that order. So if we highlight over these, on the X-axis, we will get the roll value. If we highlight the Y, we get the pitch value, and the Z, we get the yaw value. So this is the standard approach for rotations. Now, if we grab the cube, and we'll just turn this into rotation mode. So if we see that this is color coordinated, we'll get the X-axis, which is the red, and we'll be moving around the roll. So we'll be rolling the rotation, which looks like that. And obviously, if we were to go to the blue one and move this on the X, we will see that this moves sideways. So the X is sideways, Y is forward and back, and Z is up and down. And then back to the orange cube, go back into the roll, and again, we'll do the pitch. So this is the pitch of the rotation for the cube, and then the yaw will just be the final way that this can roll or rotate. And then if we press play, what we'll see is, taking into account what we've just seen there, the cube we can see is moving along its green arrow, which is the Y, so it's moving on the Y-axis forward and backwards, and this cube is going around the Z-axis, so this is going around the yaw, as we can see there. So these are the ways that we're lerping these. We're lerping one based on its location from one point in the world to another, and we're lerping the second object around its rotation, specifically the yaw rotation. And this is where in the player animation, what I've done is I kind of just approach both at the same time, because they're both lerping and doing very similar things when it comes to how we get them to move. But we do use them in slightly different ways, because it needs to account for the fact that the X, Y, and Z are not always the same. That it just needs to be represented in 3 float values, and it's easier to just keep it all looking the same until you get down to actually needing to use it in this code, the way that we do. So what we'll do is, if we go into the BP_demo, you don't need to actually code this out with me. I've got all of this ready just so that I can show some examples of what's happening. The BP demo is just the locational interpolation, and on the event begin play, we're just taking the cube and we're going into a timeline, which essentially is an animation timeline. So all we have in here, it is a timeline of 2 seconds. So over 2 seconds, we're going from the maximum value down to a minimum value, which is represented as -1. So this is essentially just a multiplication going on here. And then we are going back to the maximum value. And the reason I say that this is like a multiplication which is happening is because what we have down here is we're putting this out as the speed, and we're simply getting the actor's current location, so where it is in the world, We're then breaking this into another vector, so this is just so that we can expose the x, y, and the z, as I've mentioned. We have our 3 float values that we're interested in, and then we're turning this into a lerp. So this is where we're lerping over a vector, as we can see here. Now what we have going on is I've got the x and the z just being passed in as the x and the z of the lerp, because you'll see that I didn't want the cube to move sideways or up and down, which is the x and the z. I wanted this to stay just lerping between one axis, which is the y, which is why we're not plugging that straight in. What we're doing is we are adding a vector to another vector, which again I've split down into its 3 components, and all I'm doing is we're adding nothing to the x and the z, because again, wanted that to stay still, but we're adding 100 to the y-axis, and then we're plugging that in as the final destination. So the destination and the start point are really all that's happening in the lerp node. So we're getting the start point, which is 0, 0, and 0, and we're getting the destination, which is essentially 0 plus something and then 0. In this case it's plus 100, and then obviously this is set to loop, so this is looping. So this is basically saying start at 100 and then times that, because this is 1, and then slowly times that until you get down to -1, which would be minus 100, and then when you get to that point, times that again until you get up to 1, which would be timesing it, which would be making it again a positive value back to 100. So what we should expect, if we grab this cube when we press play, we should see this going between 2 values, and that would be between 100 and -100. So if we get the cube, we can see just here on the y-axis, that's doing exactly that. It's going between -100 or just around about -100, because you get a little bit of offset so that it can get that smoothing, so it gets just to that position. But we can see this is going to -99 to 99, so as close as we can get. So that's how this timeline is working. So what we have in a lerp node is the start point, the end point, and getting to between those points over a set amount of time, which is the alpha, which is what we're driving off of the timeline that we have here. And then all of this is simply being passed in to our set world location on the cube. So just to show how we do this from nothing, and I'm going to approach this as a completely new programmer, so coming from the point of view, you may not quite know how a lerp works, but you've heard of linear interpolation, and you know that the result that you want is a smoothing between 2 values, so you know roughly the way to approach looking for this. So I'm going to type lerp. And there we go. First thing, Unreal's helped us. It knows that we are doing this on a location. A location is represented as a vector, so it knows that we need to lerp between a vector value. And what we can do, rather than getting complex and trying to find where it is at the moment and adding a value to this, I'm just going to say, I want you to go from the 0 point in the world, so the very middle of the world, and I want you to move 200 units in every direction. So this is going to be kind of diagonal now rather than in a straight line, or that's what we'd expect, and we need this to be over a set amount of time. So I'm just going to use the timeline that we already have. So we have our alpha value, so we'll now do this over the length of 2 seconds. We're going to go from 0 in and then up to 200 units on each axis. So if we press play, there we go, we have a kind of diagonal movement, and you can see that that's moving further than it was before, so we know that that has worked successfully to go 200 units rather than 100 units, and that's how easy it is to set up a lerping vector. So that all seems nice and simple, but then we throw in adding a rotational lerp as well. So if we go over to the BP rotation, we'll see that this is very, very similar. So we have our timeline. Timelines are set up exactly the same way, so 2 seconds in length, 1 on the value, going down to -1 in value, back up to 1 in value. And then in the event graph, we have our set world rotation. So we're getting the cube and we're setting the rotation on this. And again, we're doing this in a very similar way. I'm getting the current rotation of the actor, then breaking this down because I need its X, Y, and Z, which remember the only difference really is that these are actually in fact represented in the roll, yaw, and pitch. And then we're moving this back into the roll, the yaw, and the pitch. So we're making that back into another whole vector. And the only difference here is not quite as spaghetti-like. All I wanted to affect was the yaw. So I've taken the z-axis, or the z value of the vector point. I'm adding this to be adding 100 to this, so I'm making it rotate in 180 degrees. And again, just to show, we could quickly make that rotate in 360 degrees if we wanted. So now it's doing a full rotation and then all the way back. And the only argument this needs, again, once we've made that back into its own thing, is the only argument that this will need is the starting rotation, the ending rotation, which is what we're making, and the alpha, so the amount of time that it's doing this for. and then we're plugging that in to constantly update whilst this is looping to be the rotation. So again, if we wanted to simplify this, we could just disconnect these. We could say go from your standard rotation, which is, we know that this doesn't have any rotation when it starts, and we'll add 180 in every direction. So now this should be kind of flipping around like so. So we now have a different rotation going on for the second cube, and that's all these are doing. So again, essentially represented as a vector, although here it's called a rotator, which is why if we pull off of this and say lerp, again, the engine will know that we're using a rotator, and the only differentiation here is there's still 3 floating values, but it knows that it needs to take into account that rather than being just a standard X, Y, and Z location, this is a yaw, pitch, and roll. So we get a rotator, and then again, we're just taking the alpha value as the argument for how fast we want this to happen. I'm just going to plug this back up, because there's one other thing I wanted to show, and that is quite simply that we can also obviously use this down here as well. So if we wanted to take what the current z-axis or the yaw rotation of the object was and plug that into the pitch as well as the yaw, we can update it that way too. So we get it rotating in a quite interesting way there. And you can play about this type of thing to get some really, really cool and different and interesting kind of effects. Now, as far as the timelines go, as I said, the important thing, the outcome that we're looking for here is a smoothing between 2 points. And now that's only happening because, again, we'll do this in the player movement lecture or the animation lecture, but I just wanted to recap it ahead of time, why and how we'll be getting that smoothing. So to get the smoothing, what I've done is I've added an automatic curve to this. It starts off as being linear, so I'll apply a linear animation to both of these, which is just by right-clicking on the node, then we'll compile those, and we'll press play. So all you'll notice is that rather than having this nice smooth transition between point A and point B, this is now quite rigid. It's getting all the way down until it stops, and then as soon as it's stopped, it will then get all the way back to its other position, which is the 200 to minus 200. And the same for the rotation. So all we're doing to make sure we actually get that interpolation, to make that smoothing, to just get it looking and feeling a bit nicer, is we're adding a simple curve so that it kind of eases between the points rather than just gets between the points. So hopefully that's made more sense of this. Hopefully that's going to make everything a little bit easier when you get to adding the movement and the rotation to the player animation. As I said, it was just kind of a nice to have effect. And the reason that we're using the lerping is because you do have the option of just saying to the object to just go from point A to point B without smoothing, but that looks very rigid and doesn't look very interesting to the player. So this is the reason we're looking at adding lerping. And the only real difference between the 2 different lerps that we've used is that the engine knows that we have the location and we have a rotation. And although they're both made up of 3 floating point values, what those floating point values represent are slightly different. And it takes that into account for us when we add the lerping functionality into the blueprint. And that's another thing just to keep a note in general, really, is if you highlight any of these, just to keep in mind, I think I've mentioned this before, but highlight over anything. So we have our green nodes. It will say that that is a float called speed. The new rotation is a rotator called new rotation. If we go over here, the yellow nodes are vectors, and this one's called new location. So you can tell what you will be affecting or what the thing is represented as by simply highlighting over them. And as I said, that then goes back down to a transform is just made up of 3 different vector points, the scale, the rotation, and the location. Each of those vector points are made up of 3 different float values. And it's just a nice, simple way for programs to nest things together, but obviously you still need that differentiation when you start using them for things like the difference between the location of an object and the rotation of an object. And that's what this is doing. So hopefully, as I said, hopefully that's helped to clear things up a little bit. If you did still have any questions, then do feel free to drop those in the Q&A below. But I think that should definitely get you set up and ready to add the animation for the location and the rotation into the player. So I'll leave that here, and I hope that you all enjoy the remainder of this section.